second order system analysis for underdamped case. So as previously mentioned, the output response for most physical systems are usually in an underdamped case. So the second order system is the lowest order for the system that can cause the response to be underdamped condition. So there are several specifications that can be analyzed on the output response for this system, which is TR, rise time, TP, peak time, TS, setting time, and percentage of overshoot. Let us look at one by one. For peak time TP, the time required TP is the time required to achieve the maximum overshoot peak, which is based on first oscillation. For example, this one. So the first oscillation is this part. So this is we call TP, time peak time. Maximum overshoot percentage or percentage of overshoot. This is the percentage of the highest oscillation that happen here of a system compared to its steady state value of the final value. So this is the final value for the system. So this is we call Cmax or maximum percentage of overshoot. Okay, setting time. Setting time is the time required to achieve steady state value, which is usually referred to criterion either 5% or 2% from the final value. TR, rise time. Rise time is the time required for the waveform to go from 10% to 90% of the final value. These are the formula that we can use to calculate TR, TP, TS, and percentage of overshoot. Okay, this formula is depend on the value of zeta, omega n, and omega d that we can obtain from location of pole on the S plane. Okay, for TP, peak time, so we can use this formula where TP is equal to pi divided by omega n times Z1 minus zeta square. Okay, this omega n times Z1 minus zeta square is equal to omega d. Okay, for percentage of overshoot, this part, so we can calculate by using this formula. Percentage of overshoot equal to C maximum. Okay, this value we call C maximum minus C final. Means that refer to this final value for the system at steady state condition divide by C final divided by this value times 100%. Okay. And also same, if we use this formula, exponential power of negative zeta pi divided by Z1 minus zeta square. Okay, all this we times with 100%. Okay, where Cmax in this case, in formula, we can write like this. 1 plus exponential power of negative zeta omega n, this component, divided by Z1 minus zeta square. So from here we can calculate, and also from here we can calculate zeta, where zeta, after we restructure this equation, we get zeta equal to negative ln percentage of overshoot divided by 100 divided by Z pi square plus ln square percentage of overshoot divided by 100. Okay, next, for setting time, so we can use this formula if we choose 2% criteria, where TS is equal to 4 divided by zeta omega n. Zeta omega n is a real part for the location of pole, which is referred to this as this. Okay. So for example, if we have pole at this point, so that's mean zeta omega n is the distance from this point to the origin. Okay. For if we choose criteria 5%, okay, sorry, this one is 5%, not 2%. So we can use the formula with Ts equal to 3 divided by zeta omega n. So the difference is only this one. So for 2% criteria, we use 4. For 5% criteria, we use 3 here. So for the rise time, we just use this formula where the rise time is depend on the zeta and omega n. So the formula is 2.16 zeta plus 0.6 divided by omega n. For example, for the unity feedback system represented by the transfer function Cs over Rs equal to 100 divided by S square plus 15S plus 100. So determine zeta damping ratio, omega n damping natural frequency, peak time Tp, percentage of overshoot, percentage of over S, settling time Ts, and rise time. So for solution, first we have to identify the value of omega n and zeta from this equation. So that means we have to compare this transfer function with the general transfer function for the second order system. So we know that for general order second order general transfer function for second order system is Cs over Rs equal to k omega n square divided by S square plus 2 zeta omega n S plus omega n square. So that means this component is referred to omega n square. So omega n square is equal to 100. So from here we get the omega n equal to 10. So this component 15. So if we compare with the general transfer function for the second order system, so for that transfer function, this part is 2 zeta omega n. So 2 zeta omega n here is equal to 15. So from there, we already calculate this omega n. We just put here and then we can get the value for zeta damping ratio, which is equal to 15 divided by 20 or equal to 0.79. So based on these two results, so we can use the formula that we have discussed before, where we can calculate Tp. Tp is equal to pi divided by omega n times Z1 minus zeta square. So we just put this value here and then we get Tp is equal to 0.475 second. Ts, okay, Ts, we just use formula. Okay, we consider this system, we consider we use 5%, sorry, we use 2% criteria. So Ts is equal to 4 divided by zeta omega n. So we already know the omega n and zeta, and then we just put here, and then we get Ts equal to 0.533 second. So for Tr, we just use this formula, and then we just put this the value of zeta and omega n here, and then we get the value for Tr is equal to 0.222. Now let us look at another example. For this example, we already know the location of closed loop pole. So from there, we have to determine the value of zeta, omega n, percentage of overshoot, Tp, and also Ts. So from this location of pole, we can calculate the value of omega n, okay, which is depends on the value of omega d here and the value of zeta omega n here. So by using theorem Pythagoras, we can calculate this value. Okay. So to calculate the value of zeta, we just use this theta, and the formula to calculate this zeta is cos theta. We just calculate this theta first. So how to calculate this theta? We just use theorem Pythagoras. So in this case, we can use tangent, where tangent theta is equal to 7 divided by 3. So theta is equal to inverse tangent 7 divided by 3. So in this case, we get theta is equal to 66.80 degree. So we just put in this equation and this formula, and then we can calculate the value for zeta. So zeta, after we calculate, we get 0.393. Okay, next, for percentage of overshoot, after we get the value of zeta here, so we can just use this formula to calculate the percentage of overshoot. So after we put this value in this equation, so we get percentage of overshoot for this system is 26.11%. So for TP, okay, we already know this value. This value is referred to omega D. So we just use the formula where TP is equal to pi divided by omega D. So we just put the value 7 here, and then we get TP is equal to 0.449 second. So for TS, we already know this one is zeta omega n. So zeta omega n in this case is equal to 3. So formula for TS is 4 divided by zeta omega n. So just put this value here, and then we get TS equal to 4 over 3, which is equal to 1.33 second. Okay, next.